Hi, welcome to DCO. My name is David Copete. In today's video, we'll be creating this exercise and design that is a triangulated subdivision. The pattern that we create is this truncated triangulated design that leaves a gap in the middle. We then take that pattern, create a point attractor, and then further develop it into a wireframe design that is on the inside and skin on the outside. So I'll be going over all of the steps here in detail. So if you are new or experienced, this will be perfect for you. If you have any questions, make sure you let me know in the comments below. Also, go to the website, copetidavid.com. Download the script completely for free so you can not only follow along, but you can see how everything plugged in and how I arrange my scripts. So thank you very much for being here. Hopefully you're excited on this one. This is a very useful one, not just for this pattern, but like I said, for many other designs. So I hope you're excited to get into parametric design, and let's jump into the tutorial. All right, to start here, what I do typically is I bring in a scale person. This way I can keep an eye out on the scale and I can visualize it a little bit better. Now that we have the scale person, then I like to start the script by creating a plane, a reference plane that is going to be in the X, Z. Why? Because we need to create an arc, and when we create an arc, typically it is created at the origin and it's not aligned the way that we want it to, so we can use this plane as the input to change the direction. Now we can change the radius, which is the size, and the angle. We'll just change the radius for now. We'll go 15.5. And now let's extrude this out in the Y direction. And let's create a new slider for this one, or copy this one and relabel the size. So let's call this size and this one length. Now at this stage, so we have a surface that we can apply the pattern onto. And the reason why we use this surface is because this surface is going to work as a reference plane that will not only show us if the pattern works on a flat plane, but also if it works on a surface that is not a flat plane, one that is arched like this. So now we can take this extrusion, and now let's subdivide it using Lunchbox. So if you don't have Lunchbox, go to Food for Rhino. You should be able to download it and install it. Once you install it, you'll have this tab. With Lunchbox, you'll be able to subdivide this in different ways using panels or structure. What I'll be using this time is going to be panels and triangle panels B. Now let's plug this in here, and you'll see that we already get subdivisions. And now let's change the number of subdivisions. Now to create a custom slider, I'll go to 0, less than 15, less than 30. So it'll give me a slider at 15, and it ranges from 0 to 30. This is going to be UDiv, or U division. And this one, so I'm sliding and tapping Alt to create a quick copy so I can change this to V division. What we want to do is make sure that the aspect ratio of this triangle is close to being equilateral. What that means is that this side would be the same as this side and the same as this side. Now that we have the pattern on here, we can hide the original surface and start working with the subdivision. All right, so we've got this pattern. Now what we need to do is create a subdivision of this pattern where it goes like this. Let's see if I can annotate trying this out. It's going to be a point here where it connects this dot. This connects like that, and it creates this this kind of triangle offset here. It's like a truncation. So let's hide this. Let's go back. Let me show you how to do that. So first thing we'll do is deconstruct brep. So we'll take these, we'll go to deconstruct brep, which is basically exploding it into its components. Now we can take each face and we're just going to pick one. So I'll go to list item. So we can do this just to one. Now here's the thing. If we do it to this one, it won't be the same as doing it to a middle one. So I'll actually change the index to like 5. Or a subdivision that I see that I can use as an example here. Okay. So check this out. We have this triangle. What we need to do is take the boundary and scale it down. So what do we need? We need an area component to get the midpoint. We need a scale component to scale this down. So we're going to first extract the edges by bringing in a curve component, and it'll only give you the outside boundary. Now we're going to take this and scale it. So we'll take this curve, we'll scale it down. Actually, this one, we'll leave it at factor of 1. So this stays the same size. Now we're going to take another one relative to the center midpoint. And we're going to be picking this curve. The factor is going to be 0.888 for now. And we can change this. So now what we need to do is get the midpoint of this one. So we need to explode. Which explode this into 3 segments. And also explode the ones before, because we're going to extrude this line to the midpoint. Let me show you what I mean. These segments, we need to extract the midpoint. So curve middle. Notice that we're now extracting that. We can hide everything else now. And when we scale this, those points are going to move away from each curve. Now let's extrude those to that point. So I'll go to extrude segments to which direction? Well, actually, this is not the correct component. Extrude to point. This segment goes to those points. So now if I change this and make this a smaller number, we're getting this triangle and this truncation where we now have 3 new triangles. Now, of course, we can go all the way almost closed. If you close it, actually doesn't work. So keep that in mind. Actually, if you want it to be close, you would just use the center point for all of those. So with that being said, let's go back here to 0 and let's change this from flatten to graft. What that means is that it will do it to all of them. So we can sometimes, depending on the approach, just do one module and the rest of the modules will be taken care of if everything is programmed correctly here. So let's disable the preview on most of this. Let me show you that. So what's cool about this pattern is that we can change the subdivisions and these will change with it. The way that it looks the best is when you do have an equilateral triangle, and then here we're going to be able to change the size of it. So let's do what we just did now and organize some of this, or what we did earlier. And this is going to be opening size. The smaller the number, the smaller the opening. The larger the number, the larger the opening. Now the next stage, because now we can take this and apply it to any surface. We can take this extrusion portion, or the base geometry, we'll move this over, create a relay, and even a surface component here, just in case you want to, let's say, do this. We'll create a plane here, set one surface, and use this instead. So we can apply that on any surface, but there are still some things that I want to show you because this is pretty static in the way that it sits right now. Let's create a curve attractor, and this will make it so we can definitely have a lot more control here. And yeah, I think it'll take this to a little bit more of more detail, I think. Let's type in show here, delete this. And now let's continue on creating an attractor point to change this pattern. All right, so for this point attractor, what we need to do is go back to the surface, this one, and we can do it back here, but actually we need to do it in this area past the relay, because when we apply a new surface, we needed to create the point attractor also. So now here, we'll go to a component I like to use to extract a point, which is evaluate surface. This will give us a point on a surface, so let's plug in the surface. And the point is going to be relative to this surface. Now we can plug in a specific number and use the true number relative to the design, or we can reparameterize, which lets us think of this surface as 0 to 1 and 0 to 1. And now if we place it at 0.5, we'll actually be in the middle. So the easiest way is using an MD slider, because that already gives you an X and Y of 0.5, which we can now plug into the point, and you'll see it here. This is very useful too, because it's visual in the sense that you can move it here in the graph and you can see it reacting right away. The only thing is that it's really difficult to get back to the exact number. Like if I want 0.5, it's just a little bit trickier. So what the other solution that I like to use is construct point. Let's move this down and construct this point relative to where that is going to be. So 0.5 and 0.5 in the X and Y. We'll just go 0.500 and 0.500 in the Y. And now we'll use this point as the input. And notice that now, rather than using that graph, you can now use this to move it in the X and Y, and this to move it in this direction, or U and V. So 0.5 is in the middle, this moves it to the side, 0 moves it to one side and puts it in the middle here. Let's do that for now. Okay, so we got this point. Now what an attractor does is it calculates the distance between the point and the entire pattern. So how do we do that? Well, we need to go back to our pattern here. We need to extract the midpoint, which we already have here. And now we need to connect this point to all of those. Now, there is a point attractor component, but I also like to show it this way because this is how it works behind kind of the component. We'll create a line segment starting this start point, ending at the middle of the entire pattern. So now you see that there is a line segment here that goes from this point to this one. That's a lot shorter than from here to here. And that is how it will calculate the size of it. So since it varies, we have 434 different distances, and we have here 434 objects. Now we need to change this number to vary and not just be one number. We can plug these in here, but these numbers are a little bit too large. So first of all, let's go to the length of those lines. And now, if you see here, I'll bring in a quotation marks so we can bring in a panel. And you'll see here that the numbers are really large, 21, 20. And when you're scaling something, you actually don't need a number that large. You actually need a number from 0 to 1. So we need to remap the numbers from these larger numbers to a number between 0 and 1. Let's do that. This is also on my website, capettidavid.com. Under the free resources tab, you can find the remap numbers cluster and component. So you don't have to do all of this, but let me show you. We'll take the length, that will go into the value. Source is going to be using bounds, which is the biggest and smallest number. So the biggest number let's flatten this one. The biggest number we have is 38. The smallest number we have is 0.8. And that goes into the source. Now the target is what numbers do we want to create? So construct. Let's try that again. Construct domain. Now this is what we are trying to target, which is from 0 to 1, 1.0000. We'll create 2 of them. One at a lower number. You don't want 0. And you don't want 1. So somewhere in between 0 and 1. Now we can plug that into the target. So what this component does is it will scale down the figures from these really large numbers to these numbers between 0.951 and 0.76, which is this. So now all the numbers have been shrunk down to that range. And now we can do this and plug that into the factor. Now here is the catch. When we look at this number that is coming out of here, it comes out as a list that is not grafted. We actually need to graft this number that's coming out of here. And I'm just using this more as a visual. You can also right click on top of the output and graft. Now we can take this and plug it into the factor. So notice that however close this point is to whatever it is, it's smaller, and as it gets further away, it starts getting loose. And we can do the opposite as well, where we take this, make it tight, and then make it loose where the point attractor is. Now notice that there's a ton of overlap here. So what we need to do to clarify things and see them is to first move some of this stuff to organize it, and then hide the preview on most of it except the output. And in terms of the point attractor, well, now it's at this corner. We can go to the other corner, or we could go right to the middle, 0.5 and 0.5. And in some instances, we don't want it to be too large. In some instances, we do. So here it almost goes from an open form to this closed form back here. Okay, let's organize some of this stuff because there's a few more steps that I want to show that will be critical in terms of adding more detail and make it more functional, right? So what I mean by making it more functional is this would be really hard to develop because they're just planes. So what we need to do is offset the original surface and create a wireframe, and then have this pattern be within the wireframe. So the first thing I'll do is decrease the number of subdivisions to make it a little bit easier. And now let's develop the structure, which is going to be like a wireframe design here. All right, so let's go back to our surface, this one, or this one. We're going to now join those panels because we want to extract just a wireframe. So we'll go to brep join. If you don't see the components the way that I see them, it's because it's under display and I just have everything on. So now that we have this joined, I like to hide this wire just because sometimes it gets in the way, and this is going to be a separate portion of the design. From the breps, we'll get the edges. So brep edges. We need to flatten the input. And now that we have the edges, we can develop it two ways. One, using pipes, or the other way would be using sub D multi-pipe. I think that's what I'll use. So multi-pipe, I like to merge both the exterior and interior curves. And now we can use those as the curves input to create a wireframe design. Now for multi-pipes, I like to use 3 components. This is just a technique that I use because there are a lot of inputs, but there are only a few that make the biggest impact. One being strut size, the other one and offset, and node size. So now you'll see here that these two at the top will take care of the connection, and this one down here, the strut size, just want to see so I'm just splitting. I'm actually going to split the outside and inside ones to 2 separate components, even though they'll look like it's just one. All right, for now, actually, let me hide the pattern so we can look at this. And let's decrease some of this, play around with the connection portion. Let's say this is good for now. Okay. Now let's go back to the pattern. Okay, so the pattern is now overlapping with our struts. We can either place the pattern on the outside or we can offset the pattern to the inside. So this is the interesting part, is that now we're going to take this surface and we're going to offset it. And we're going to offset it by a distance, let's say 0.150. And notice it's offsetting to the outside. We'll actually want it to go to the inside. So we'll go to negative direction. And I'll take this and hide the wire display. We will take this offset surface and subdivide it in the exact same way that we subdivided the pattern. Now we take a look at it here like this. And now we can also, let's see, so we got this. Now we need to join it and we'll plug back into this one. So notice now that if we look at it in elevation view, we have this component and we have this component. Now we have the offset. So now we're seeing that the pattern will be on the outside and the structure on the inside. So how do we ensure and we see this correctly? Well, let's change some of the color here. Now to preview this, we'll go to custom preview and then change this to color picker or color swatch. But actually color picker has been lately the one that I've been using. And I bring it back here even though it's a bit of a weird way to connect that, but I just like to see the color behind the component. And then I hide both of the wires here. Now we're going to take this and copy it. Hide this. Now plug that in. They're both the same, so now this will become for the pattern. Do you see how there are some overlaps here? Let's go back to the offset surface, hide it. And so now the panels are on the outside. You can't really see them, but let's increase this and this. Now we'll also create a copy of this. We'll plug in these panels and that will become the glass panels. So we'll change the transparency. And the offset. Okay, now we're going to take the pattern and extrude it up to give it some depth. Because if we were to develop this, these segments would actually be attached to the structure there. So let's first hide this. And now we're going to take that pattern and extrude it out. Now notice that every single one of these has a different normal. What that means is it has a different direction for the perpendicular of the surface. So what we need to do is extrude every surface perpendicular to the surface. And we can do that by extruding it and using amplitude. because amplitude will use the surface normal as the vector, and we'll use these extrusions as the base input for the extrude. And now this vector is going to be the amount that it will be extruded by. The reason why it's grafted is because every single one of these has a different normal, so you only have to do that to the corresponding ones. So let's go to amplitude, we'll go point. Notice that I always do a few decimal points here. And it's extruding down. So we need to extrude the opposite direction. Either put a negative component in here or put a negative component in here. Now I've seen that in Blender, you can just take this component, and if it's going to go in between that wire, you can just go like this and it'll work. I think that would be a cool feature to have here, but regardless of that, now we have this as our input. We can hide the rest. So let's change the lens length. Okay. Now let's try a different base surface. I'll go here to a circle and extrude this up. And we'll set this as a surface and use this as the input. And the pattern changes. Same with a surface like this. So if we type in plane, cage edit, line segment. So this is the other pattern here, using a different type of surface. So for now, I will leave this with the original surface, this one. Let's bring this back to all right. So this will conclude this tutorial. There are a few other things that we could do to change this up from just being a pattern like this. We could also offset frames to the inside. But hopefully this gets you started with creating patterns on a surface, developing it further from just a wireframe to creating truncated subdivided panels, curve attractor or point attractor, and then developing the rest of the structure. So thank you very much for being here. Check out the website capettidavid.com. You can download this script completely for free until the next video is released, and you'll be able to use that for your project. So thank you very much for being here, and I hope to see you on the next video.